guys, Mr. Klein here with our third and final lesson of our chapter on the different types of elements. Let's go ahead and let's get going with this. So, in our last lesson, we talked about the periodic table, and we talked about how there are groups that are vertical, periods that are horizontal. And you might be wondering, what are the general types of elements? Well, that's what we're going to talk about in this lesson. We can generally divide elements into one of three categories. We can divide them as metals, nonmetals, or metalloids. So that's what we're going to be talking about here. In the periodic table, the vast majority of elements are what we call metals. Metals are simply elements that are good conductors of heat and electricity. And you can find metals on the left-hand side of the periodic table. So most elements are actually metals. And let's look at some and things like gold and iron and silver and things like that are metals. And so some general properties of metals are as follows. First off, they're usually shiny. Most of them are shiny. Many of them are malleable or easily bent. If you can apply heat, you can bend it. Like you've seen a wire and you can bend it and do stuff like that. They generally take electrons when bonding. They form ions, which is why they can conduct electricity so well. And also, almost all metals are solids at room temperature. The biggest example of a metal that is not a solid at room temperature is actually mercury. The stuff used in temperature scales, they're liquids. So let's go ahead and let's create a graphic organizer in order to organize all this information. Okay, metals are on the left side of the periodic table. Like I said, they're shiny, they're malleable, they take electrons when bonding, and they're almost all solids at room temperature. And we'll talk about the categories in a minute. So go ahead and set up your graphic organizer to look like this. You might want to pause right now in order to get this. So I'm glad that you've created your graphic organizer. So let's look at some categories of metals. We're going to talk about the different groups and them. Okay, in the periodic table, we have 5 classes of metals. The first ones are alkali metals in group 1. They're highly reactive. Things like sodium are alkali metals. They're soft and react almost instantaneously. The second group are alkaline earth metals, and they're in group 2. They're very reactive also. No, not quite as alkali metals. A good example of an alkaline earth metal is actually calcium. Okay, the stuff that your bones are made out of. That's an alkaline earth metal. Transition metals are in groups 3 through 12. That's most of the metals. They're generally hard, shiny, and silver colored. And we have 2 groups of transition metals. Those are the elements that you see kind of at the bottom of the periodic table, the ones kind of off by their lonesome. And they are the elements that follow lanthanum. Those are called the lanthanides, and they are shiny and pretty reactive. And then below them are the elements that follow actinium. We call them the actinides. They're all radioactive, and they break down into more stable elements over time. So these are 5 classes of metals. So let's go ahead and let's put them in our graphic organizer. Okay, we have the alkali metals, that's group 1. The alkaline earth metals, that's group 2. Groups 3 through 12 are the transition metals, and underneath them are the lanthanides and the actinides. Okay, so just kind of know what they are generally, and for purposes of our class, we just need to know what they are and maybe a couple of examples for them. So those are metals, okay? So the other group are nonmetals. Nonmetals are elements that are poor conductors of heat and electricity. They're kind of the opposite of metals, okay? You can find them on the right side of the periodic table. There's not as many, but they actually create about 99% of all matter in the universe. Like I said, they're the opposite of metals, and they have the following properties. Most of them are gases at room temperature, but bromine, for instance, is a liquid. Carbon's usually a solid. In addition, solid nonmetals are the opposite. So they're not shiny, they're rather dull in color. They're also brittle, or they break easily. Remember, most metals are hard, so the opposite, they break easily. And they generally, instead of taking electrons, they usually share electrons. They believe that sharing means caring. They usually share electrons when bonding, and later on this year we'll talk about ionic and covalent bonds. Covalent bonds always involve nonmetals. So let's go ahead and let's fill out our graphic organizer right here. Okay, we have our metals, we filled all that out. Nonmetals, they're on the right side, which is the opposite of metals. Non-metals, like I said, are mostly gases at room temperature. Bromine's a liquid, carbon's usually a solid. When they're solids, they're dull colored, they're not shiny. They're brittle, which means they break easily, and they share electrons when bonding. Okay, so that's the basics of nonmetals. Let's look at a couple of categories of nonmetals. There's 6 nonmetals who aren't in a group. We just call them nonmetals, but they have 2 specific groups. The first ones are halogens. Halogens are all highly reactive nonmetals, and they react violently with alkalis. Chlorine is an example. Salt, sodium chloride, is made out of sodium, an alkali metal, and chlorine, a halogen. Okay, they usually react violently, but then once they react, they usually stabilize. The noble gases are in group 18. Okay, they're off by themselves. They're special because they almost never react with other elements. And the reason why is their outer shell of electrons is full of electrons, so they don't need the bond. They don't need electrons in order to be happy. And we'll talk about bonding in an upcoming chapter. And so this will make more sense when you know there. So just know that they're kind of the opposite of alkali metals. Alkali metals want to react with everything. Noble gases don't react at all. So let's go ahead and let's add the halogens and noble gases right there. So you might be looking and you say, okay, Mr. Kine, we have left side, right side, we have stuff in the middle. Well, what do you mean by that? Well, we're talking about metalloids, okay? And between metals and nonmetals, like I said, are metalloids. And metalloids are just elements with properties of both metals and nonmetals. They're kind of a mixture of both. Some metals are shiny while other ones are dull, so it's kind of a mix between the two. Some metalloids will conduct electricity, but only at certain temperatures. Other times they won't conduct electricity. As a result, because they only conduct electricity at certain times, we call them semiconductors. Silicon would be a great example of a metalloid. So let's go ahead and let's fill in our graphic organizer right here. They're between metals and nonmetals. They have properties of both. Some are dull and some are semiconductors. So here you go. This is our lesson. We talked about just the general categories of metals, nonmetals, and metalloids. Metals are on the left side. They're shiny. They take electrons. They bond. When they bond, they're solids at room temperatures. They're mostly hard, especially the transition metals. And we talk about alkali metals, alkaline earth metals, and the transition metals. The opposite, of course, are nonmetals. They're mostly gases. When they're solid, they're dull and they're brittle. They're weak, but they share electrons. Halogens and noble gases are examples of nonmetals, and nonmetals make up 99% of all elements in the universe as far as we know. And in between is a small group that we call metalloids. They have properties of both, so they're kind of a mixture of them. So there you go. That's the lesson just on the general properties of the elements. And we'll go in our next chapters on chemical reactions and bonding and how they stick together. So as always, if you have any questions, please let me know, and thanks for watching.